Good afternoon, everyone. Good
Good
afternoon,
afternoon, sir.
everyone.
Good afternoon, sir.
So, what we were doing yesterday?
Sir, examples on one-sided limit.
The sequential criteria of one-sided limit.
Yes, so we defined one-sided limits, both LHL and RHL, right? And then we did a theorem on one-sided limit. So, in fact, we noted that the sequential criteria for limit which was holding for limits, it will also hold for one-sided limit with little adjustment, okay, with little changes. And the algebra of limits theorem that we did for limit of a function, that will also hold for one-sided limit. So you should remember this fact. We are not going. Okay, so we are not going to write all those results, but they will all hold for this one-sided limits also. All the limit theorems that we did for limit of a function will hold for one-sided limits. Okay. So is this whiteboard visible to everyone?
Yes, sir.
Okay. So what results we did for limit of a function? कौन कौन से रिजल्ट्स करे थे हमने लिमिट ऑफ अ फंक्शन के लिए? So पहले तो थी बाउंडेड थ्योरम, बाउंडेडनेस थ्योरम, राइट? कि if limit extends to c fx equal to is exist, then क्या होता है? f is bounded in some neighborhood of c, right? Remember this result? Yes.
Yes, sir.
Analogous to this result, we have result for one-sided limit. So what is that? What will be that limit? If I will say limit x tends to c, positive fx exists, what it will mean? Then there exists delta greater than 0 such that, and m greater than 0, क्या होगा? Such that mod fx is less than m for all x belonging to, कहाँ पे x belong करेगा?
C to infinity.
C to C plus delta, बल्कि C को इसमें इंक्लूड कर सकते हो तुम, if it is defined at C, ठीक है? C to C plus delta. इस नेबरहुड में C to infinity नहीं होगा, नेबरहुड में होगा. वहां पे नेबरहुड क्या होता है? वहां पे पूरा नेबरहुड होता है C to C plus delta. सो उसके जब भी हम वन साइडेड लिमिट्स की बात करेंगे तो जस्ट हम इस इंटरवल को वी विल रिप्लेस बाय आइदर दिस इंटरवल. So we will replace by this interval when we will talk of left LHL, तो ये इस इंटरवल से रिप्लेस कर देंगे. और अगर RHL की बात करनी होगी तो we will replace by this interval. बाकी सब कुछ सेम रहेगा, ठीक है? So एक हो जाएगा x belonging to a, x not equal to c की जगह या तो x greater than c या x less than c depending on LHL RHL, और ये वाले इंटरवल को we will replace by this interval. बाकी सब कुछ सेम रहेगा, ठीक है? So all the limit theorems that we did for limit of a function, that will also hold for this one-sided limits, ठीक है? So we are not going to write those theorems, but ये सारे के सारे hold करेंगे, ठीक है? तो कहीं पे हम यूज कर सकते हैं विदाउट प्रॉपरली स्टेटिंग हियर, ठीक है? तो रिमार्क या वी कैन राइट आल्सो. चलो लिख ही लेते हैं थ्योरम्स, जल्दी जल्दी हो जाएगा. ओके, सो लेट if a is contained in R, f is a function from a to R, and then f from a to R has f from a to R be such that limit x tends to c positive fx exists. Okay, c is a cluster point of A intersection C infinity. Then there exists delta greater than 0, m greater than 0, such that what will happen? Your fx is less than equal to m for all x belonging to A intersection C to C plus delta. ठीक है, x belongs to A intersection C to C plus delta. Yes. And yes, okay, so this is boundedness theorem for right hand limit. ठीक है, then उसके बाद कौन सी थ्योरम करी थी? एक तो ये थ्योरम करी थी, then we did algebra of limits theorem, right? So similar to, yeah, analogous लिख देते हैं, similar. So analogous to algebra of limit of a function, we have algebra of one-sided limits. ठीक है, सेम रिजल्ट होल्ड करेंगे, सम जो है वो सम की तरह हो जाएगा, डिफरेंस वो सारा सब कुछ सेम होल्ड करेगा. फाइन, यस. उसके बाद और कौन सा, उसके बाद हमने कौन सा रिजल्ट करा था? क्विज थ्योरम, राइट, वो भी होल्ड करेगा. क्विज थ्योरम for one-sided limit, again same result will hold. So क्या स्टेटमेंट होगी इसकी, बता सकता है कोई? What should be the statement? Yes.
Sir, if fx is less than gx is less than hx and limit of hx is equal to limit of gx, then that is also equal to limit of hx.
Yes. So let A contained in R, f, g, h be functions from A to R such that fx is less than equal to gx is less than equal to hx for all x belonging to A intersection C to infinity. Okay. So A intersection C to infinity. Then so हमें लेफ्ट में देखने की जरूरत भी नहीं है, हमें राइट में ही बस चाहिए होगा. And if limit x tends to C positive fx is equal to limit x tends to C positive hx, then limit x tends to C positive gx exist C equal to L, तो क्या हो जाएगा? Exist and limit x tends to C positive gx is equal to L on. ठीक है, so same result and similar to this LHL left hand limit will also exist. ठीक है, so skew theorem भी hold करता है. और उसके बाद हमने और कौन सा रिजल्ट करा था? So we are not writing the proof, लेकिन एग्जाम में they may ask you a proof of or this, instead of asking the proof for limit of a function they might ask you the proof for this. So उसमें कहीं बस तुम्हें हर जगह क्या करना होगा, अगर xn नॉट इक्वल टू c है तो उसकी जगह xn ग्रेटर देन c लिखना होगा. जहां पे वी आर राइटिंग द इंटरवल c माइनस डेल्टा टू c प्लस डेल्टा, वहां पे आइदर यू विल राइट c टू c प्लस डेल्टा और c माइनस डेल्टा टू c. ठीक है, लेफ्ट साइड ऑफ c या राइट साइड ऑफ c, पूरा c के अराउंड दोनों साइड नहीं लेना है, बस यही चेंजेस आएंगे, बाकी ज्यादा कुछ नहीं आएगा. फाइन. And then we did a theorem, last theorem, which was एक थ्योरम बची थी पॉजिटिव वाली, वो क्या थी थ्योरम? व्हाट वाज द स्टेटमेंट? Let A be contained in R, f be a function from A to R, and let C be a cluster point of A. So we are taking C to be a cluster point of A intersection C infinity because we are talking about right hand side limit. अगर left side में बोलते तो minus infinity to C आ जाता. So यहीं पे changes आएंगे. एक तो ये आता है change और बाकी वो जो हम कर रहे हैं दिखा रहे हैं. So then what will happen? If limit x tends to C positive fx is greater than 0, then there exists क्या होगा? Then fx is positive in some neighborhood of yes. So there exists delta greater than 0 such that fx is greater than 0 for all x belonging to A intersection C to C plus delta. ठीक है? Simple कि fx is positive in some right neighborhood of C. ठीक है? Is it fine? So similarly we will have similar results will hold for this left hand limit also. इसमें यहाँ पे लिख सकते हो respectively or limit x tends to C negative, oh sorry, C positive fx is less than 0, then so this will hold. Fx is less than 0 for all x belonging to A intersection C to C plus delta. Okay, so this is the theorem. Similar results will hold for LHL also. ठीक है, with ठीक है LHL में बस ब्रैकेट और वो सब चेंज वो हमारे चेंज हो जाएंगे इंटरवल्स, बाकी सारे सेम रिजल्ट्स होल्ड करेंगे. ओके फाइन. सो ये सारे रिजल्ट्स को याद कर लेना और इनको मतलब क्योंकि अप्लाई करना होगा तो हम कई बार ये रिजल्ट्स भी अप्लाई करेंगे. फाइन. सो लेट अस नाउ डू सम एग्जांपल्स ऑफ वन साइडेड लिमिट्स. एग्जांपल्स ऑफ वन साइडेड लिमिट्स. वैसे कल तो एक कराई था, आज और करेंगे. Okay. So first is question show that the first example is this example, very important example. Show that for the function gx equal to e to the power 1 by x, x not equal to 0, limit x tends to 0 positive gx does not exist and limit x tends to 0 negative gx is equal to 0. ठीक है. और इस क्वेश्चन को ये भी पूछ सकते थे कि शो दैट लिमिट x टेंड्स टू 0 gx डज नॉट एग्जिस्ट. तो उस केस में यू विल फाइंड उस केस में तो बस RHL निकाल दोगे, उसमें शो कर दोगे कि RHL डज नॉट एग्जिस्ट सो लिमिट विल नॉट एग्जिस्ट. ओके, लेट अस ट्राई टू प्रूव दिस. सो कैसे करोगे इसे? e to the power 1 by x
The sequential criteria.
कौन सी सीक्वेंस?
So 1 by n.
यस 1 by n सीक्वेंस. सो उससे क्या होगा?
वो तो 0 पे कन्वर्ज कर जाएगा सर.
नहीं नहीं, 0 पे कहाँ, इनफाइनाइट अनबाउंडेड हो जाएगा इन नेबरहुड ऑफ. ठीक है.
xn तो 0 पे जाएगा सर. g to the power xn अनबाउंडेड होगा.
So consider the sequence xn where xn is equal to 1 by n for all n belonging to n, right? So this is a sequence in 0 to infinity where, so this is a sequence in 0 to infinity. हमें क्योंकि 0 से right में लेना है, so we have to take a sequence in 0 to infinity. So we have got a sequence of 0 in 0 to infinity. Now what about gxn?
e to the power n.
Gxn will be e to the power 1 by xn, which is equal to e to the power n. ठीक है? And which is greater than
Bound.
n. Right? This result we know for all n belonging to n. So this implies gxn is an unbounded sequence and hence not convergent. Right? So then by sequential criteria for one-sided limit, by sequential criteria for one-sided limit, what we will have? Limit x tends to 0 positive, gx does not exist. Okay, we are able to find a sequence that is converging to 0, but its corresponding sequence is not convergent. So by sequential criteria for one-sided limit, this does not exist. Okay, is it fine? या इसे बाय सीक्वेंशियल क्राइटेरिया की जगह बाय डाइवर्जेंस क्राइटेरिया भी लिख सकते हो, जो भी लिखोगे सही रहेगा. Okay, now what about the second part? Limit x tends to 0 negative gx equal to 0. What you will do in this case?
एप्सिलॉन का लेटर डेफिनेशन यूज करेंगे.
Yes, we can use the epsilon letter definition, लेकिन उसमें क्या आ जाएगा? E1 by x आ जाएगा. ठीक है, अब E1 by x से how you will get x? You have to get, see, तुम्हें क्या करना है? तुम्हें E1 by x minus 0. You want to show this, so you will get this E1 by x, and somehow you have to get the relation in terms of x. How you will get this? Because you want to get x minus 0, so that means
log ले लेंगे सर.
क्या
log
log से कैसे inequality ये कैसे show करोगे? This inequality, can you show this inequality?
सर ये तो हमेशा पॉजिटिव होगा सर, e to the power 1 by x. तो लेस देन एप्सिलॉन आएगा तो फिर 1 by x लेस देन ln एप्सिलॉन. ln फंक्शन इंक्रीजिंग होता है, इक्वालिटी पे कोई फर्क पड़ेगा नहीं. x 0 नहीं है सर, तो log x डिफाइन ही हो जाएगा.
नहीं, log x का कहाँ से यहाँ पे कहाँ यूज हो पाएगा log x? You want to show this inequality. इसमें log कहाँ से लाओगे log? Somehow you want to get this because तब तुम delta equal to epsilon लेके लिख सकते हो. ठीक है, so, इसके लिए हम सिंपल ये वाली इनइक्वालिटी को यूज करेंगे. ठीक है, अभी लेट अस सी दिस इनइक्वालिटी. नाउ वी विल क्लेम लिमिट, अभी जो ऊपर यूज करिए ना सेम इनइक्वालिटी वी विल यूज. लिमिट x टेंड्स टू 0 नेगेटिव gx is equal to 0. So we will take let epsilon greater than 0 be any real number. Okay, I'm getting a call, just wait a minute. Okay, so we can do this. What we will do is we will start with any epsilon greater than 0. So let epsilon be any real number. Okay, so we are starting with any epsilon. Then now we want to consider. So we want to show this fx is 0, right? So this is our e1 by x minus 0, and this is e1 by x. Now we want it in the form of k times mod x minus 0. We want it in this form. Okay. But remember our x will, because we are talking of left hand limit only, so our x will be less than 0. Okay. Our x will be less than 0. So mark it as 1. Now we know that 0 is less than t less than et for all t greater than 0. Can someone prove this result? अगर if I will ask them to prove this result, can someone prove? कैसे करोगे इसे prove? Very simple result. मतलब देखने से तो पता चलता ही है. So how you gonna prove it?
सर x जो है हमेशा ग्रेटर देन होगा ln x से, फिर बोथ साइड बेस e ले लेंगे तो ये आ जाएगा.
बेटा फिर तो वही उल्टा रिजल्ट यूज कर रहे हो. वहां पे तुम यू आर यूजिंग दिस रिजल्ट कि t is greater than ln t. So सिंपल रिजल्ट ना, ये तो अगेन यू आर यूजिंग दिस रिजल्ट, और ये दोनों तो इक्विवेलेंट रिजल्ट्स हैं, राइट? सो इस चाहे ये प्रूव करो या ये प्रूव करो, बात एक ही है. सो हाउ यू विल प्रूव दिस? कभी भी इनइक्वालिटी प्रूव करना हो तो सबसे बेस्ट चीज क्या होती है? You can, what you can do is you can take f some function ft equal to et minus t. ठीक है, so we want it to be, we want to prove it greater than 0. ठीक है, so 0 तक t greater than 0 पे चेक करना है. so ऐसा फंक्शन चाहिए जिसमें कि यहाँ पे जो है ये ft greater than f0 आ जाना चाहिए हमारे पास. ठीक है, ठीक है, we will prove that it is increasing function, so we will prove that ft is greater than f0. so f0 क्या आएगा यहाँ पे? 1. ठीक है, which is greater than 0, so उससे अपने आप हो जाएगा. so let us start this. so f dash t क्या होगा तुम्हारा यहाँ पे?
e to the power t minus 1.
e to the power t minus 1. so is it positive or negative for t greater than 0?
पॉजिटिव.
why?
Because
e to the power t greater than 1.
Yes, et is greater than 0 for t greater, because et is an increasing function, so et is greater than e0, which is equal to 1, right? Again, so this will be greater than 0, so increasing function, right? so this is an increasing function, so ft will be greater than f0, that is et minus t is greater than 1, and this is greater than 0, so this implies et is greater than t. so this is, जब भी कोई inequality होती है you can prove like this only कि उसको increasing शो कर दो उस इंटरवल पे, so या decreasing शो करके, मतलब कुछ भी inequality जिस तरह से प्रूव करनी है, so उस तरह से inequality लेके then you can prove increasing और decreasing. ठीक है, so this is, ठीक है, ये वैसे रिजल्ट ऑब्वियस सा है, यू ऑल नो दिस रिजल्ट, क्योंकि et की वैल्यू हमेशा t से बड़ी होती है, यू ऑल नो दिस रिजल्ट, बट स्टिल इफ यू आर आस्क्ड टू प्रूव देन यू कैन प्रूव लाइक दिस, जैसे अभी मैंने बताया कि ft को, और बाकी बाद में वी विल लर्न मोर मेथड्स टू प्रूव दिस टाइप्स ऑफ रिजल्ट्स. हम मीन वैल्यू थ्योरम से कर सकते हैं, देन वी कैन डू फॉर यूजिंग टेलर्स थ्योरम आल्सो, सो दैट वी विल लर्न लेटर ऑन, बट ये तो बेसिक इनइक्वालिटी है, दिस वी कैन प्रूव डायरेक्टली आल्सो यूजिंग इंक्रीजिंग डिक्रीजिंग. ठीक है, so अब इस इनइक्वालिटी को हमें इसमें यूज करना है. now since x is less than 0, या for x less than 0 let t equal to let so use t, so इसमें t equal to, ठीक है, this is greater than 0, so we can use this in above inequality. So हमारे पास क्या आएगा, 0 is less than minus 1 by x is less than e to the power minus 1 by x, ठीक है. And what does this imply? For all x less than 0. So this implies, अब क्या करेंगे, we will reciprocate it. So this will we will get, so this will be 1 by x क्योंकि ये already minus है, and this is less than minus x, ठीक है, for all x less than 0. So this implies e to the power 1 by x is less than mod x for all x less than 0, because mod x is nothing but minus x because x is less than 0, ठीक है, fine.
Yes.
So using 2 and 1 we have gx minus 0 is less than mod x for all x less than 0. So let delta equal to epsilon, then by the choice of delta gx minus 0 is less than epsilon whenever your क्या होगा,
x less than c minus delta to c
माइनस डेल्टा लेस देन x लेस देन 0, ठीक है, ये वाला इंटरवल आएगा, c माइनस डेल्टा टू ये होता है ना 2x to c, so c is this 0, so minus delta to this, ठीक है. Fine. So hence
Yes.
by definition of one-sided limit x tends to 0 negative gx is equal to 0. But जो ये epsilon delta definition use करने की बजाय what we can do is, because we have done so many results, so we can directly also prove this using this inequality. So instead of doing all those things, we can simply prove this by squeeze theorem, ठीक है. Alternate proof for limit x tends to 0 negative gx equal to 0. वो मैंने बस इसलिए करा दिया epsilon delta definition से कि you should know how to write that also. But generally हम जो है ये वन साइडेड लिमिट्स के रिजल्ट्स हम या तो सीक्वेंशियल क्राइटेरिया से करेंगे या स्क्वीज थ्योरम से करेंगे, ठीक है. So we have to show this. So what we will do for all x less than 0, okay, तो सेम ये बिल्कुल कॉपी कर देंगे यहाँ से हम, just copy this, okay. So we know this, so for x this is there, and so this implies 0 is less than e1 by x is less than minus x for all x less than 0. So using squeeze theorem, since limit x tends to 0 negative 0 is equal to 0 constant functions left side, and this is equal to limit x tends to 0 negative minus x. So this so by squeeze theorem for one-sided limit x tends to 0 negative e1 by x is equal to 0, क्योंकि इसका भी लिमिट 0 है, इसका भी लिमिट 0 है, so by squeeze theorem इसका भी लिमिट 0 होगा, ठीक है. So simple proof. So generally हमने, क्योंकि we have done so many results now, so we will, instead of using epsilon delta, we will generally use these types of results, squeeze theorem, then sequential criteria. So ये results को हम use करेंगे, ठीक है. Fine. Is it fine everyone?
Yes sir.
Yes, sir. Yes, sir.
Okay, now let us take another question of this type. So show that for hx equal to 1 upon e1 by x plus 1 e1 by x plus 1 x not equal to 0, limit x tends to 0 hx equal to 0. So this we have to show. 0 positive hx equal to 0 and limit x tends to 0 negative hx equal to 1. Fine. तो कैसे करोगे इसे?
One by x lies between 0 to the power 1 by x.
Yes, अभी हमने इसके लिए let us so first claim is claim 1. We are going to prove this limit x tends to 0 positive hx equal to 0. So we will take x greater than 0. So for x greater than 0, we know that 0 is less than 1 by x less than e1 by x. ठीक है, वही रिजल्ट को या एक लाइन और ऐड कर सकते हो so that बाद में भी तुम्हें convenient रहे. So we know that 0 is less than t less than et for t greater than 0. So for x greater than 0 using t equal to 1 by x in above inequality हमारे पास क्या आ जाएगा? 0 is less than 1 by x is less than e to the power 1 by x. ठीक है, now we want to get this inequality. So ये फॉर्म चाहिए हमें. So ये कैसे आएगा?
So 1 by x is less than e to the power 1 by x. Then sir, after that we will take.
नहीं, पहले देखो डिनोमिनेटर में देखो, it is of the form e1 by x plus 1. So you have to add plus 1 here, right?
Yes, sir.
So add. So इस वाले को अभी ये greater than 0 को let us forget, ये अभी requirement नहीं है. So add 1 to both sides. So this will imply 1 by x plus 1 is less than e 1 by x plus 1, right? Yes.
Yes, sir.
और इसको हम इस तरह से भी, it would be better we start to make it so for all x greater than 0. This is there. Now we start with this 0 is less than 1 upon ex plus 1, right? तो अब अगर डिनोमिनेटर में से 1 रिप्लेस करेंगे तो क्या होगा?
1 by e to the power 1 by x.
Yes, the number will increase because we are decreasing the denominator, right?
Yes, sir.
And this is less than, since e1 by x is smaller than e1 by x plus 1. ठीक है, ये वाली inequality. And this is less than
X.
या 1 upon 1 by x लिख दो एक बार. ठीक है, because 1 by x is less than e1 by x and this is equal to x. So what we got is 0 is less than 1 upon e1 by x plus 1 less than x for all x greater than 0. So by since limit x tends to 0 positive 0 is equal to 0 and this is equal to limit x tends to 0 positive x. So by squeeze theorem what we will have? Limit x tends to 0 positive 1 upon e1 by x plus 1 is equal to 0. ठीक है, so we have used the squeeze theorem. Left side 0 होता है, right side is converging to 0 when we take limit, when we approach x from the right side of 0. So this will also approach to 0. ठीक है, same to limit x tends to 0 negative 1 upon e1 by x plus 1 is equal to 1. Now देखो यहाँ पे तो क्योंकि ये लिमिट एग्जिस्ट नहीं करती, ठीक है, दिस लिमिट x tends to 0 positive e1 by x, this does not exist. That's why we are not able to use our algebra of limits, right, कि नीचे लेके algebra of limit लगा दिया, but क्योंकि left hand limit इसकी exist करती है, so we can use algebra of limits. Since limit x tends to 0 negative e1 by x which is equal to 0 exists, so by algebra of limits, algebra of one-sided limit क्या हो जाएगा हमारे पास, लिमिट x tends to 0 negative 1 upon e1 by x plus 1 will be equal to 1 upon limit x tends to 0 negative e1 by x plus 1, right? Yes. Is it right?
Yes, sir.
Yes, sir.
Okay, and this will imply, so this will imply 1 plus 0 plus 1 which is equal to 1. बाकी अदरवाइज तुम इस तरह का इनइक्वालिटी करके स्क्वीज थ्योरम लगा के भी कर सकते थे. You could have used this type of inequality also, और स्क्वीज थ्योरम लगा के ला सकते थे. So that you can try yourself, but एक मेथड ये भी है, because we have done, तो एग्जाम में अगर आ जाए तो prove this result and then use this. ठीक है, either prove this result and prove this, और इसको इनइक्वालिटी की तरह करके भी कर सकते हो. ट्राई टू फाइंड एन इनइक्वालिटी जिसमें इधर 1 आ जाए, इधर भी 1 कुछ आ जाए, so that the limit is equal to 1. Fine. जैसे
Yes, sir.
हमने इनफैक्ट ये प्रूव करा हुआ है ना, 0 इज लेस देन e1 by x इज लेस देन माइनस x फॉर ऑल x लेस देन 0. रिमेंबर, ये पहले प्रूव करा था हमने लास्ट पार्ट में. तो अब व्हेन यू विल ऐड 1 ऑन बोथ ऑल द साइड्स, सो दिस विल बिकम e1 by x plus 1 and this will become 1 minus x. So when you will take the reciprocal, so inequalities will change. This will become this, right, and this will become 1 upon 1 minus x. So when you will take the limit as x tends to 0 negative, so this will approach to 1, this will approach to 1, so by squeeze theorem this will approach to 1. Okay, so you can use this inequality also and then write the proof, or you can use this algebra of whichever way you like. Okay, or let us write the alternate proof for limit x tends to 0 negative 1 upon e1 by x plus 1 equal to 1. So we know that 0 is less than t less than et for all t greater than 0. So for x less than 0, using t equal to minus 1 by x in above inequality, we get 0 is less than minus 1 by x less than e minus 1 by x for all x less than 0, and this will imply 0 is less than e1 by x less than minus x for all x less than 0. अच्छा, ये ध्यान रखना कि इस जब हम रेसिप्रोकेट कर रहे हैं तो इसको नहीं रेसिप्रोकेट कर रहे हैं, ठीक है, क्योंकि 1 by 0 तो इज नॉट डिफाइंड, सो वी आर नॉट रेसिप्रोकेटिंग दिस, बट क्योंकि ये अभी भी पॉजिटिव है, दैट्स व्हाई वी आर एबल टू राइट दिस. ये रेसिप्रोकेट करने की वजह से नहीं आ रहा है, ठीक है, ये ध्यान रखना. बस हम ये इन दोनों को रेसिप्रोकेट कर रहे हैं, दिस इज ऑलवेज ट्रू, इसीलिए ये चीज होल्ड कर रही है, ये रेसिप्रोकेशन से नहीं आ रहा क्योंकि 1/0 तो अनडिफाइंड हो जाएगा, ठीक है। एंड so this we got, now add 1 to all sides, so 1 less than ex plus 1 less than 1 minus x for all x less than 0, ठीक है, and this will imply 1 is greater than 1 upon e 1 by x plus 1 is greater than 1 by 1 minus x for all x less than 0. So by now since limit x tends to 0 negative 1 is equal to 1 is equal to limit x tends to 0 negative 1 upon 1 minus x, hence by squeeze theorem for one-sided limit x tends to 0 negative 1 upon e1 by x plus 1 is equal to 1. Fine. Is it clear everyone? तो दोनों जो एग्जांपल हमने करे हैं are they clear? Okay, so this is how you can prove all such type of examples. Let me give you the graph of these two functions जो अभी हम कर रहे हैं. So this is the graph of ex equal to e1 by x. So as you can see here, limit x tends to, so from when you are approaching 0, this is 0. So when you are approaching 0 from the left side, so you are approaching to the value 0, while when you are approaching 0 from the right side, you are going to infinity. So it does not exist, right? So limit x tends to 0 positive, dx does not exist, right? While this limit x tends to 0 negative, gx is equal to 0, right? This is approaching to 0. So this is the graph of gx equal to e1 by x, and then we have this graph for hx equal to 1 upon e1 by x. Let's see how that behaves. So as you can see, when we are approaching 0 from the right side, where we are going? We are going to 0, right? Limit x tends to 0 positive, hx is equal to, what was it? 0, right? And while when we are approaching 0 from the left side, so when we are approaching 0 from the left side, our fx is going to 1, right? Hx is going to 1. Okay. Okay, so let's end this class here only. Any doubt, anyone? किसी को कुछ क्वेश्चन पूछना है? Okay, so since there are no questions, let us end this meeting now. Okay, bye everyone. Have a good day.
Thank you, sir.
Thank you, sir.